Hello children, how are you all? Hope you all are doing well. This is Krishnamurthy. You can call me as VKM, working at Basidia as a chemistry faculty. In previous session, we had discussed about physical properties of amines. In today's session, we are going to talk about chemical properties of amines. In this lecture, preliminarily I'll be focusing on basic character of the amines, which is a very important topic for any competitive examinations as well as for board examinations also. Let's talk about. So under chemical properties, there are so many chemical reactions, but we are majorly focusing on basic character of amines. Basic character of amines. Children, amines are examples of bases. How can you say that amines are examples of bases? Because the central atom, nitrogen, which is consisting of lone pair of electrons or unshared pair of electrons, because of the presence of these lone pair of electrons, they can be considered as Lewis bases. They can be considered as Lewis bases. Possessing electron density doesn't mean it can act as a base. It has to donate that pair of electrons. A lone pair of electrons should be donated to the other species. So these amines can act as a Lewis bases when they react with acids. These amines, when they react with acids, they can form salts. They can form salts like RNH2 plus HX. RNH2 plus HX. Hydrogen halide is an example of acid. So it can be dissociated as H plus and X minus. Right? So this lone pair can be given to the H plus and it forms a salt. That salt is RNH3 plus and X minus. It is an example of salt. Similarly, if you take an aromatic amine, that aromatic amine when reacts with HCl, aromatic amine like aniline, it is reacting with HCl, it forms anilinium chloride. It forms anilinium chloride because lone pair can be donated to this H plus and it forms anilinium chloride. In that case also, aniline is acting as a base. In previous case, this primary amine is also acting as a base. Lone pair of electrons present on the nitrogen has been donated to an acidic hydrogen and it forms a salt. Hence, those primary amines or aromatic amines are amines. In simple, they can act as a base. Right? Now, if you observe that, those amine salts, what we got it? Those amine salts are NH3 plus X minus. Those amine salts, when they treated with a base, like NaOH, like KOH, right? When they treat it with base, you will get your parent amine. That primary amine can be regenerated. Here, the parent amine is primary amine plus H2O and X minus. That primary amine can be regenerated. Whatever the amine salts which are formed by treatment of primary amine with an acid, you will get salt. That salt, if it is furtherly treated with base, you will get your original primary amine or parent amine. Hope you understand that point. So, if you talk about this basic character or basic nature of the amines in detail, if I take RNH2 and dissolve it in water, water can exist in the form of H plus and OH minus ions. That H plus ion do not have any independent existence and it forms RNH3 plus and OH minus ions will be released out. And if you write the expression dissociation constant of base, that is called Kb. Kb stands for dissociation constant of base. Dissociation constant of base. How do you write it? Kb is equal to concentration of RNH3 plus N2 concentration of OH minus upon concentration of RNH2. We will not include concentration of H2O because practically water should be taken in excess. When we take water is in excess amounts, concentration of that water should be kept at constant. That's why we are not including in the equilibrium constant expression. Here that equilibrium constant is Kb, and that Kb can be called as dissociation constant of the base. In that, we can give the relationship that is pKb. pKb is equal to minus log Kb. Or else I can write it as pKb is equal to 1 upon log Kb. Both are same. So that means pKb is inversely proportional to Kb. If Kb value increases, pKb value decreases. If Kb value decreases, pKb value increases. But Kb is directly proportional to the basic strength. If Kb value is increasing in the sense, basic strength increases. Basic strength increases. And Kb value decreases in the sense, basic strength decreases. Basic strength decreases. So, if Kb is more, basic strength is more. If the base is having low pKb value, basic strength is high. If base is having high pKb value, basic strength is low. So such a way you have to identify based on pKb and Kb values. Those are experimentally observed values. Those are not theoretical values. If Kb increases, basic strength increases. If Kb decreases, basic strength decreases. That Kb you can find it out with the help of this expression. With the help of that expression. So now the most important point, if we take different amines, how do you decide the basic character of those amines? How do you decide the basic character of those amines? First, let's compare between alkanamines versus ammonia. Alkanamines versus ammonia. Alkanamines means it may be primary or it may be secondary or tertiary or aliphatic amines. Simply aliphatic amines. In another way, you can say aliphatic amines. Understood? And if I take an aliphatic amine, RNH2, it gives its lone pair or electron density to H plus and it forms RNH3 plus. RNH3 plus. But if I take ammonia, it gives its lone pair of electron to H plus. It forms NH4 plus. It forms NH4 plus. Observe it. For suppose if this is a base and this must be conjugate acid. We have learnt in the class 11 conjugate acid base theory or Bronsted-Lowry's acid base theory. If this is a base, it is a conjugate acid. Similarly, if this is a base and it is a conjugate acid. If this conjugate acid is stabilized by any means, there is no equilibrium, backward reaction. There is no backward reaction, hence corresponding base is stronger base. Corresponding base is a stronger base. If you observe here, this nitrogen is having electron deficiency. That's why it acquires positive charge, right? It has donated its lone pair. But it is connected to R. R means alkyl group. R means alkyl group. Alkyl group is an example of ERG, electron releasing group. It operates plus I effect, positive inductive effect. So it donates its electron density to nitrogen. By that, nitrogen electron deficiency somehow up to some extent it can be fulfilled. By that, this conjugate acid becomes stable and there is no backward reaction, hence base is stronger. But in case of ammonia, it gives a conjugate acid which is not associated with any electron releasing groups. It is associated only with the hydrogens. Hence it is not getting stabilized. So there may be a possibility of backward reaction. Hence it can act as a weak base compared to aliphatic amines. So when you establish the comparison, when you establish the comparison in gaseous phase only. I am talking about in gaseous phase. Observe it carefully. In gaseous phase, out of ammonia and aliphatic amines, which are stronger bases? Aliphatic amines are stronger bases. So if you observe that in aliphatic amines itself, we have primary amine, secondary amine, and tertiary amine. These are the three types of amines we have, right? And primary amine, that is NH, and it is R. RNH, and it is R. RNR, which is having lone pair of electron density. Right? So in the first case, in case of primary amine, how many alkyl groups are there? Only one alkyl group is there. Here, two alkyl groups are there, which gives electron density to the nitrogen. As number of alkyl groups increases, electron density also increases. By that, they can act as a strong basis. Moreover, in the previous case, if you observe it, here this conjugate acid which is formed here, after donation of its lone pair, a conjugate acid is formed. That conjugate acid also gets stabilized because of these alkyl groups. Those alkyl groups can operate a positive inductive effect. Hence, conjugate acid gets stabilized. The extent of stability increases. So, out of primary, secondary and tertiary amines in gaseous phase, which amine is stronger base? In the sense, what you will say? Tertiary amine is stronger than, secondary amine is stronger than, primary amine is stronger than our poor base, that is ammonia. So, by that we can say, as a concluding point, we can say that ammonia is weak base than aliphatic amines. All these are together called aliphatic amines, right? Or alkanamines, right? Hope you understand. Alkanamines are stronger bases due to the presence of alkyl groups which can operate positive inductive effect, which can act as electron releasing groups, and conjugate acid, if it is formed, it gets stabilized by those alkyl groups. Hence, alkanamines are stronger bases than ammonia. Hope you understand. But this order to be followed in gas phase. Only in gas phase that follows the order. But when we consider in aqueous phase, or in aqueous solution, how do you explain the basic character of amines? It can be explained, basic character of amines can be explained by number one, inductive effect. Which inductive effect it is? Plus I effect. According to inductive effect, same like gaseous phase, tertiary amine is stronger than secondary is stronger than primary. That is done. And next effect we have solvation effect. What is that? Solvation effect. Because our amine, we have dissolved it in water now. Aqueous phase means we have dissolved it in water. Water is a solvent. That solvent has the ability to form hydrogen bonds. What I mean to say, RNH2 I have taken, if you dissolve it in water, then it forms RNH3 plus and OH minus. If this is a base, RNH3 plus is an example of conjugate acid, right? If this conjugate acid is stabilized by any means, corresponding base is stronger. That's a stronger base. And here in aqueous solution, this conjugate acid is stabilized by hydrogen bonds. This is a conjugate acid of which amine? Primary amine. Conjugate acid of a primary amine, right? So that conjugate acid of primary amine, how it can be stabilized, that you can understand here. RN H, 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 nitrogen develops positive charge. So this hydrogen can form hydrogen bond with water. This hydrogen can form hydrogen bond with water. This hydrogen can form hydrogen bond with water. Like that, how many hydrogen bonds are there? 3 hydrogen bonds are there. Similarly, if I take conjugate acid of the which one? Secondary amine, then Rn, R, it is H and develops positive charge, of course. It develops hydrogen bonding and it also develops hydrogen bonding. So the first one what I have given, that is the conjugate acid of the primary amine. Conjugate acid of primary amine. But the second one what I gave here, this is conjugate acid of secondary amine. Now what about tertiary amine? Observe it. Rn, it is R, and it is H. And nitrogen develops positive charge. Only it forms one hydrogen bond. Only it forms one hydrogen bond with oxygen of water. So, conjugate acid of primary amine has how many hydrogen bonds? 3 hydrogen bonds. Secondary amine has how many hydrogen bonds? 2 hydrogen bonds. Tertiary amine has how many hydrogen bonds? Only 1 hydrogen bond. So, then which is more stable? As extent of or as number of hydrogen bonds increases, extent of stability also increases. If it is more stable, corresponding base is stronger. That means according to which effect? According to solvation effect, if you observe that, order of basic strength is given as primary amine is stronger base than secondary is stronger than tertiary. Right? And we have another effect, that is steric effect. That is steric effect, or else you can say steric hindrance. Steric effect also need to be considered. In steric effect, if you observe it, it is N having lone pair R, H, H. It's a primary amine. It is a secondary amine. And similarly, having lone pair R, R, R. It is a tertiary amine. So which has more alkyl groups? Tertiary amine has more alkyl groups. It's primary, it is secondary, and it is a tertiary. So nitrogen is having lone pair of electrons. It is ready to donate. It is ready to donate to the acidic H plus ion. So then when it wants to donate the lone pair of electrons to H plus ions, these alkyl groups are bulky. These alkyl groups are bulky in nature. Because of this bulkiness, nitrogen cannot donate the lone pair of electrons because these bulky alkyl groups offers steric hindrance. They try to, hinder. They try to hinder. Let us say if it is a lone pair, consider here lone pair, this lone pair wants to give it to H plus, right? This, and you consider it as alkyl group. That alkyl group will not allow this lone pair to give it to the H plus because it is creating a bulkiness. Right? So if you observe, when we go to any function, there itself bouncers used to be there. When you don't have a pass, they won't allow you. Right? Bouncers are creating the steric hindrance. Similarly, here also alkyl groups are creating steric hindrance. Due to that, lone pairs are less available for donation. But in which amine lone pairs are more available for donation? In primary amine, lone pairs are more available for donation, because only one alkyl group is there. But in secondary amine, 2 alkyl groups are there. So according to steric effect, order can be given as, what is the order to be followed here? Primary greater than, secondary greater than, tertiary. Right? So we got 3 orders if you observe it. One is based on which one? Inductive effect. Based on inductive effect, what is the order? 3 degree greater than, 2 degree greater than primary. Second effect, solvation effect. Based on solvation effect, what is the order? 1 degree greater than, 2 degree greater than, 3 degree. A third one, what we have? Steric effect. Based on steric effect, what we have? 1 degree greater than, 2 degree greater than, 3 degree. So summing up of all these, effects, the final order of the basic strength in aqueous solution can be given as order of basic strength can be given as 2 degree greater than, 1 degree greater than, 3 degree greater than ammonia, but this case is for R is methyl group. For suppose if R is ethyl group, then 2 degree greater than, 3 degree greater than, 1 degree greater than ammonia. In this case, R must be ethyl group, that is C2H5. So secondary amine is a stronger base compared to primary and compared to 3 degree. So we have to balance or compensate all the three effects. By summing up of all these three effects, we can say that secondary amine is the stronger base compared to primary. Primary amine is stronger base compared to tertiary. And when R is methyl group, like methylamine, right? So methylamine, dimethylamine, trimethylamine. Which is stronger base? Dimethylamine is stronger base than methylamine than trimethylamine. If it is ethyl, diethylamine is stronger than triethylamine. Triethylamine is stronger than 1 degree. This is the order to be followed in which phase? Aqueous phase, right? Now we need to compare basic strength of aromatic amines are also said to be aryl amines. Aryl amines versus ammonia. Aryl amines versus ammonia. See, earlier we have compared alkanamines or aliphatic amines versus ammonia. What we have concluded there? Ammonia is weaker base than aliphatic amines. Aromatic or aryl amines when it is compared with ammonia. So here I am taking simple aromatic amine. What is that? C6H5NH2. Nitrogen is having lone pair. It is ready to donate. But that lone pair is involved in resonance with the benzene ring. That lone pair is involved in resonance with the benzene ring. Then what will happen if I polarize the bond in this way? Right? It gives a resonance structure. It gives a resonance structure. This nitrogen develops positive charge. So here minus, and I can polarize the bond in this way. This minus and plus can form a bond over here. It develops a negative charge, and here NH2 plus. And I can polarize the bond in this way. I can give another resonance structure, that is here NH2 plus, and this minus and plus can form a bond here, and it gets negative charge. Next, we are polarizing the bond. We are giving these electrons towards nitrogen. This minus plus develops a bond over there. These are the resonance structures can be given for which species? Aniline. Its lone pair has been retained. That lone pair has been retained over there. So, aniline, if you observe that in aniline, lone pair of electrons are not available for donation. Those lone pair of electrons are involved in resonance with the benzene ring. Hence, it can act as a weak base. Hence, it can act as a weak base compared to ammonia. In ammonia, ammonia formula is NH3. In that, lone pair of electrons is available. But in case of aniline, when we talk about it, so lone pair of electrons are not available. What I'll write it here? In aniline, lone pair is not available for donation. Not available for donation, as they involved in resonance. Right? So then, what is the order can be given? C6H5NH2 is a weak base compared to ammonia. So aniline is a weak base compared to ammonia. Hope you understand. So now the overall comparison, if you give it, aliphatic amines are stronger bases than ammonia. Ammonia is stronger base than aromatic amine. This is the overall basic strength can be given. Hope you understand that. Aromatic amines are weaker bases compared to ammonia and compared to aliphatic amines. Now, if electron releasing group is there, ERG increases the basic strength. ERG increases the basic strength. EWG, electron withdrawing group, decreases the basic strength. So, basic strength is directly proportional to plus I or plus M, inversely proportional to minus I or minus M. So let us say if I take, OCH3, right, OH and CH3, these type of groups increases the basic strength because those are plus M groups. But if I take NO2, SO3H, COOH, right, so and as well as CHO, these type of groups decreases the basic strength because these are EWGs, electron withdrawing groups, but these are ERGs. Electron releasing groups increases the basic strength, electron withdrawing groups decreases the basic strength. So it is the overall topic of basic strength of amines or basic character of amines. So basic character of amines can be explained in gaseous phase with the help of inductive effect. In aqueous phase, it can be explained with the help of three effects: inductive, solvation, steric effect. By that, we have concluded the final order. When we compare aryl amines and ammonia, ammonia is stronger than aryl amines because in aryl amines, lone pair of electrons are involved in resonance. The final conclusion I have given: aliphatic amines are stronger bases than ammonia. Ammonia is stronger base than aromatic amine. Hope you have enjoyed the session. In the next session, we will continue the remaining chemical properties. In this session only, we have discussed the basic character of ammonias. Right? So we'll catch up in the next session. Until then, take care. Bye. Signing off. Thank you.